So then probably the presentation should be within 12 minutes or so. Then for each presentations, probably we will actually have a kind of question and answer sessions. Okay, so then let me start the presentation. So I would like to invite the first speaker. I hope that he is now in online. As far as I heard that Professor Sarawit Narpiti from Chulalongkorn University will have a presentation through the teleconference or the Zoom or whatever. So then, Professor Sarawit, do you hear us? Is he online? No, not show up. If not, we may. Do you have any connection? Is he trying to access? Should I change the order of presentation?
ฮัลโหลฮัลโหลครับอาจารย์สรวิทย์ได้ยินไหมครับครับพูดนะไม่ดัง
Okay. Could you talk first? Okay. Okay, anyway, while waiting for Professor Sarawit to come, probably I may just wanted to change the order of presentation. So anyway, I would like to invite the second speaker, Professor Lantevin, and also the Dr. Gwendin Tuan, the Hanoi University of Science Technology. Okay. Would you kindly actually show the PowerPoint on for the second speaker? Oh, no.
ได้ยินปกติ
คือของเราตอนนี้
ฮัลโหลฮัลโหล
เสียงปกติครับแต่ของเขา
อาจารย์ได้ยินไหมครับอาจารย์ได้ยินใช่ไหมครับอาจารย์เปิดไมค์แล้วใช่ไหมครับเหมือนทางเสียงอันนี้จะไม่เข้าของเราอันนี้เดี๋ยวรอสักครู่นะครับอาจารย์เสียงมันไม่เข้าเสียงไมค์ของทางฝั่งอาจารย์ครับไม่มี
เสียง
เสียง
จาก
มา
ซูมนะครับไม่เข้า
ลองให้เขาสลับเป็นเขาได้ไหมคือของอาจารย์เสียงไม่เข้าแต่ว่าพูดอยู่เดี๋ยว
ใช้ได้ไหม
อาจารย์คนไหน
ข้ออาจารย์
เดี๋ยว
Oh, really? Let's see.
So, and then
ฮัลโหลครับ
we can
มา
see
แล้ว
โอเค
โอเคครับ อาจารย์พูดเลยครับ
Okay, I think everyone could hear me now.
So, you mean the first speaker? Sorry? I see. Okay. Thank you.
Okay,
Yes, please, Professor Saravit Narupiti. But
Yes.
probably you may have a slide.
yes, I have slide. Did you see it?
Not
I-
yet.
I put my slide on already.
I see. Okay. Just a moment. What we see now is just a kind of, let's say, movie of myself. Unfortunately.
It will be the first page of my slide. Hope that you can see it now.
No, just a moment.
Okay, let me try again.
It's okay.
Coming?
Okay, yes. We could see your desktop now.
It should be the first page of my slide.
Yes, we could see the
I-
cover page.
Yes. Okay. All right. Maybe
Okay.
I would like to
Yes,
start.
please start.
Okay, thank you very much, Professor Shibasaki, and sorry for delay. I would like to present my topic on leverage multi-GNSS for one application for advanced traffic analysis. Okay, let me introduce myself briefly. I am the associate professor at Chulalongkorn University in Bangkok, Thailand. And my interest is on intelligent transport systems. So I use a lot of vehicle tracking data, probe data. I do a lot of analytics, then further to connected automated vehicle and also smart mobility. Okay, and hope you see my slide well. This is overview on multi-GNSS in transportation. We can use a lot of multi-GNSS in many applications in transportation sector, from tracking, fleet management, and also today I will focus on traffic flow analysis, and but also we can do further for the future mobility and the new kind of the mobility like driving assistance. Okay, and I give you background on multi-GNSS tracking in Thailand. By law, some types of vehicles has to equip some tracking devices from large trucks, buses, public vans, and taxis. Currently, we have more than 500,000 vehicles equipped with these tracking devices and manage the data by GPS center, by Department of Land Transport. And for them, they use it for regulating, monitoring those vehicles. For example, speeding, overtime work hours, or identify drivers. Unfortunately, they don't disclose or share the data to other organizations. So we don't see a lot of wider applications in Thailand. And we have another organization called Intelligent Traffic Information Center, or ITIC. And they collect all kinds of transportation data, including tracking data. Tracking data is one of the key data in this organization. And now they have right around 100,000 vehicle tracking data in a day. So this is the example in one time, maybe we have more than 50,000 vehicles tracking data online. And we can zoom in and see where those data come from. And we can see in a particular location. And let me zoom in again. Now we can see even individual vehicles that provide us data. It could be taxi, it could be delivery trucks, or the pink locations yet identify types of vehicles. But of course, we can get data from these vehicles or locations. So those are current situations on vehicle tracking data in Thailand. Now I move to my main topic for today. the role of GNSS for traffic analysis and management. As I mentioned, GNSS can be used for many applications, from analysis of flow pattern or identify problem areas to real-time monitoring and real-time traffic signal control. I will introduce to you two projects that we have done it in Bangkok, Thailand. One is academic study, and the other is a big project called Rama 4 Model Project. And the first one is actually a study at Chulalongkorn University. We want to see the quality of the data that we can get from taxi tracking data. And we obtained this data from one taxi company. The strength of this data was it's quite frequent, every 3 to 5 seconds. So we analyzed the driving behaviors and also traffic condition. So by individual, and we selected only one segment of the road, which is in downtown Bangkok, Rama 4 Road. And on this road, we kind of analyze individual data from all individual vehicles. We can plot vehicle trajectory, so we can obtain a lot of traffic data, like where that vehicle stopped, and the behavior of slow down and speed up, and even the speed they operated on one road section. So we obtain a lot of results, but again, these are a lot of results. So I want to skip this one, but again, we have confidence that the data has a good quality, and we can do further applications for transportation. The next project is Rama 4 Model Project, which is a big project started in 2019. It lasts for 3 years. And this is the real implementation projects that we try to solve traffic management problems. And we learned that in the past, we don't have a lot of data to start with. So in this project, we called our project data-centric approach, because we want to start with the data. And we seek for many sources of data. And the one in the highlight is the existing available data that we tried to use data from ITIC and also Grab company, as well as we install new sensors on the roadway. This data could give us more reliable, more accessible, and more timely. Now, what we do with the data, we want to have 3 things from the data. Use the data to get insights what happened. Use the data for decision-making, better decision-making, and use data to collaborate with all stakeholders. So with this one, I show you briefly on what we found. Well, to solve the congestion, we need to understand the traffic condition. And in the past, very difficult to know what happened. Well, we can see by own eyes, but we don't have data. And now we obtain data from Grab Taxi. And you can see that individual journey, we can plot it. And then we can plot it together to obtain the journey, the trajectory of each vehicle. And then we know the movement, we know the distribution, and we can cluster it. Okay. And okay, let me. And once we convert it into congestion hotspot, this is easy to see by officials that where the congestion occurred. So I think it's quite good for the traffic manager to obtain what happened on the road. See, we can identify hotspots or where the heavy congestion occurred on Rama 4 Road. Okay, next, not only we obtain the congestion, but because we collect data continuously over almost 1 year, so we know exactly what happened in the big data. So we can build a new indicator, what's so-called congestion index. This is good in a sense that we learn more than just the current speed, and we understand more congestion more thoroughly. And we built up dashboard so that the officials can take a look and can obtain everything quite easily. It's be useful for management purpose. Okay. And next, we presented this to the official, namely Bangkok Metropolitan Administration. They like it a lot. They use it to identify congestion areas, actually ranking 1 to 20, where the congestion occur the most. And we can dig deep down to each location, try to understand the root cause of the problems. For instance, we look at the one in the middle. We see it's not only the problem occur not only in that area, but on the surrounding area. And we combine this method with other methods like field operation and talking with stakeholders, so we can identify the congestion and root cause of the congestion quite thoroughly and efficiently. And because we collect the data in a longer period of time, once we implement something, we can see the before-after evaluation. Okay, let me summarize my talk because the time is limited. I show you the status of GNSS vehicle tracking in Thailand. And you see that we have a lot of probe data in Thailand, but we need to use it for the wider and useful applications. We had a small project on analysis of taxi probe data. We learned about the quality of the data. We learned how to analyze the data, and it demonstrated potential applications. We have big project on Rama 4 module project that we realize the benefit of data in traffic management, and we have the real implementation on Rama 4. We talk with a lot of officers, and they like it a lot. They like to see the data, they like to see the results from the data. And this one, we use probe data as the main source. So we can get a lot of traffic insights, enhanced our traffic management, and it's good for decision making. Okay, that's all for my presentation. Thank you very much.
Okay, yeah, thank you very much, Professor Sarawait. I'm surprised to see that how rich your data are. Okay, so then from the floor, I would like to have, we would like to have any questions or comments or whatever. Any questions or comments? Okay, yes. And would you kindly come up to the stage just to the microphone so that Dr. Sarawait could hear you?
Hello. Yeah. Thank you very much, Professor, for the great sharing. I'm just wondering if the current database that you're producing is accessible for both decision makers and users or passengers. What are your main targets of the database?
Okay, the result from the project, all officials can access our database and use. Unfortunately, one of the big data we got is from company. So we have like agreement that we don't provide raw data to anyone else. But let me add one thing. ITIC that I mentioned, they provide open data. And this is very popular. I heard from many people in many countries, they use this ITIC open data. Yes, so you can check out the ITIC open data.
IT open data.
ITIC, yeah.
Okay.
ITIC open data.
All right. Thank you very much.
Yep.
Okay, thank you very much. And any other questions or comments? Just one short question. In Bangkok, actually, lot of investment have been made to improve the public transportation, like railways. So, do you anticipate any kind of, let's say, collaboration or kind of annual cooperation to reduce the road traffic demand itself? I mean, the kind of modal shift.
Oh, That's our dream, though. Yeah, we built a lot of infrastructure, especially public transportation. So we attract people to use public transportation. Yes, we want to do so. But the real implementation, there's still a gap that we cannot bring people out of the cars. But again, it's getting better and better when we build a more extensive public transportation. I think that we need to see another minor problems that prevent us to have the benefits. For example, the feeder systems that we lack of. Yeah, secondary public transportation that we.
I see. Okay, yeah, thank you very much. Okay, Professor Sorowit Narputi. Yeah, thank you very much for your presentation. Thank you. Okay, then may I invite the second speaker, Professor Lantebin and also the Professor Gwendin Tuan, Hanoi University of the Science and Technology. Good. Oh, good.
Okay. Okay, thank you. Okay, thank you, Professor Shibasaki. Today I will come here to say with you about one of the using its GNSS technology for for testing the vehicle checking box in Vietnam. So I think this is one of the also using the GNSS technology here is applied in our products. So first I will show you what is a vehicle checking box, and that I think that also is a story of Vietnam. Also, for using the vehicle checking box for public vehicle, we have currently we have some limitation of testing and validating checking box before using for the equipping for the vehicle. Also, from the limitation we propose, and now that is accepted for using the GNSS simulator for validating the checking box in Vietnam. And I will give you very short about the Navisim architecture. It's not only the simulator; it's the combination of the GNSS simulator and the IoT solution for validating the checking box. And also I will show you some performance evaluation and some picture of the how they using the GNSS simulator in the validating and testing the vehicle checking box. The first, as you see on the slide, that is the checking box, and as a requirement of the government, all of the public transportation in Vietnam must be equipped with the checking device. So the checking device will send the data, including the position, velocity, and also the time, every second to the data center of the directorate abroad. Yes, for in case of the accident or any time the government they want to see what happened with the public transport public vehicles, they can see in the data center. And up to now there are around 1 million public vehicles that already is equipped with the checking box. And that's before the equipping the checking device to the public vehicle, the authority must be the test and also the validate the device. Currently, the solution for the for the test and also the validate the checking box is using the real vehicle. It means they have to test some the scenarios such as the device must be alert by the beeping when the device is when the speed is over 80 km per hour. And second, if the driver driving continuously over 4 hours, the device must be giving an alert. So that is to test the device. They must be put the checking box on the car, and then they drive over 80 km and also continuously over 4 hours. So to see the behavior of the checking box. So with the testing, the testing scenario, there are some limitations. First, that is quite dangerous because if you drive continuously for more than 4 hours, and sometimes you have to drive over speed, that will be very dangerous and also tired. And another limitation that you cannot repeat the same test for on device because you may know. In some cases, for example, if in case of the bad weather, some GNSS receiver cannot work well. Or if you drive in the, for example, in the center of the city with a lot of the high building, the behavior of the GNSS receiver may be not as you expected. So that will raise another problem. So that is the reason why we propose we can use the GNSS simulator for testing the device. Because as you may know, using the GNSS simulator, we can control the own of the environmental conditions, such as you can show how many satellite you want, and also the power of every satellite. Also, you can repeat the same test over and over again, and also limit the unintended interference signal. Especially, it's emerging problem in Vietnam now. So, using the GNSS simulator for the evaluating the performance of GNSS receiver, must be, I think it's much faster and more accurate than using the practical testing as before. But using the commercial GNSS simulator, we have some problem. First is that it cannot flexible with many scenarios following the regulation in Vietnam. And also, we cannot connect directly the GNSS receiver to automated testing. That is a problem. That is the reason why we using the combine the GNSS simulator with the IoT solution for automated testing GNSS receiver in the black box. So that is our product. So our product actually is not the combination of two things. So first is the GNSS simulator, and second, that is the IoT solution for automated testing, as I mentioned before. So this one, with the simulator, we can do we have some options. First, we can simulate the GNSS signal completely, or we can record and play back. Because in some cases, such as in some days we get the reporting, there are a lot of the jamming, or in some scenario we can record the data and play back to see the action. The action of the receiver is case of the hazardous environments. Also, because using the GNSS simulator, so we can provide the API to user for if they want to manipulate they want to they want to control the simulator, and also they want to change the scenario as they want. So actually the simulator integrated in the Navisim is a software-defined simulator. We use a front end. Everything is generated in the software, including the generated the trajectory, the modulating the digital signal, and then the digital signal is transmitted through the front end. The front end that is commercial. The front end such as USP, you can buy easy to buy on the market. Also, the data is stored to playback to hard disk for playing later. So that is I can show you very quickly about the architecture of our simulator. The simulator is contain two parts. The first, that is the input of the simulator. That is the trajectory and also the ephemeris. The ephemeris you can easily to download from the IGS or from the GNSS receiver. From that we will modulate the signal. If the user they want to generate a multipath, or they want to generate some interference such as radio frequency interference, they can check the option and then choose some parameter for the interference. From that, the signal is applied to front-end filter and the quantizing signal, and then they have the two solutions. First is store to disk or send directly to the front-end to transmit real time. Okay, this one I think I can skip because of the limit of time. So that is for the interface for the Navisim for the checking box. So you can see that is very simple. One the screen and also the GNSS output. There are the 4 outputs. We can connect to multiple satellite. Multiple receiver for testing. If the user want to test 10 or more receiver at the same time, they can using the GNSS splitter to split the signal. I will show you through the image later. And here, for example, we using our simulator to see how the performance of two brands of the checking box in Vietnam. You can see, yeah, it's very easy to evaluate the performance of the GNSS receiver integrating into the checking box. And also this one is for the centimeter checking box. And here is the image. You can see that is the National Center for Technical Progress. That is one of the organizations. They have the outright for testing the device, checking box device before provide the certain certificate for the company. And they use our simulator for the testing and verifying the device. You can see using our simulator, now they can stay in the office and test how many scenarios they want with the own of the checking box with the same scenario, environmental condition. Okay, that is the story I want to show you about the story Vietnam and also the solution for testing and also validating the GNSS receiver inside the checking box in Vietnam. Thank you so much. Okay.
Thank you so much. Yeah, that is really interesting kind of project and also device. I just wonder how expensive it is. Okay, any questions or comments from the floor? Yeah, anyway, such sort of the research is really necessary for implementing kind of, let's say, GNSS-based tracking of the commercial vehicles.
Yeah.
Oh, okay, yes.
Thank you very much for the great sharing. I'm wondering how you store the data. I think you use SD card, right? Yeah, is it overwriting or you need to store the data to other devices? If you are taking a lot of simulations maybe every day. Yeah. Do you use SD card for storing?
Sorry, you mean the data from the receiver or the data in the simulator? Yeah. Yes, this one?
Yeah.
Yes, as I saw you, because it depends on the user. They have the two solution, two options. The first, if they want to play real time, the data from the quantizing signal will directly stream to the front end and then transmit to the outside. Yes.
Okay.
Or if they want to store the data and then for playback later, yes, they can to store to the hard disk.
Hard disk. Okay.
Yeah.
So it's not overwriting.
Yeah, actually, because the hard disk inside the simulator is very, it's very huge, about 1 to 2 terabytes. Because the data for the digital light signal is very heavy. It's about for store 1 second. It takes us 80 megabytes.
80 megabytes.
Yes. Yeah.
Okay.
So it 1 second. That's only 1 second. So it
Every second.
yeah.
Okay.
So we have to store. We need a very huge capacity of the hard disk.
Okay. Same like Prof. Shibasaki. How much is it?
Actually, as I told you, because this one is one kind of the spoofer. That one actually is
spoofer,
considered is a simplistic spoofer. This is the reason we have in Vietnam we do not have any regulation for selling the product to the customer. The normal customer. So the product now is just provide for the government and authority for testing and the checking device.
Not for sale. Thank you very much.
Thank you.
Okay.
Thank you very
Thanks
much.
so much.
Okay. Yeah. Would you kindly come up to the stage for microphone?
Thank you for presentation. So for typical vehicle navigation, you need also other sensors such as odometry or gyro sensor is also used. So for your GNS simulator,
Yeah.
do you have plan to add such kind of additional sensor?
Actually, for in our simulator, we do not integrate any IMU sensor or something like this. So this one is, as I show you, just for the checking the black box. Inside the black box is a very low price in Vietnam, and that is the reason in the black box this GNS receiver inside the black box is also the very low price. There are no the fusion sensor inside the black box.
Okay.
So up to now,
you're just focusing on such kind of
yeah,
application.
yeah.
Okay, understood. Thank you very much.
Okay, thank you so much.
Okay, yeah, thank you very much. That is really interesting, and yeah. Okay, so then, may I invite the next speaker, Professor Fitri Yaakob, University of the Technology Malaysia. Probably you are supposed to be the third speaker. Are you ready for that? Yes. Yes. Anyway, you have 10 minutes. Okay. Ooh.
So is it okay if I proceed after this?
Hmm?
Sorry? Can I proceed after the next one? I need to set up.
I see. Okay. May I change the order of presentation? Okay. So then, while he's anyway getting prepared, I would like to invite the Dr. Ling Yola, University of Indonesia.
Can you please project?
Oh, okay.
Thank you very much, Prof. Shibasaki. Hello, everyone. I'm Lin Yola and my colleague Garin Nandito. We are from Universitas Indonesia, Jakarta, and we are here to share one of our works titled Integrated Technology of GNSS and Environmental Sensor for Mobile Air Monitoring Applications for Transjakarta Bus Rapid Transit. I think we've shared this work in some forums, but today we are going to share the updates of the works. Jakarta faced the pollutions for years, but it became worse since 2019, and the most problematic one was last year, 2023. And it cost 11,000 deaths in Jakarta, including premature deaths, and costs a lot of costs for that. And you see, this is the level of the air pollutions in Jakarta, 177 ACI index, and this is 21 times above the standard of WHO. And as you can see, the red one are the most highest one in the city. For comparison, I was checking just now the quality index, air quality index in Bangkok. It ranged 127. Not so far, but yeah, this is categorized as unhealthy for sensitive groups, while for Jakarta is unhealthy for everybody. So Bangkok, though this is not so good news, but you are better than us in Jakarta. And you see, there are some red spots in Bangkok, but you also have a lot of yellow and orange spots. And this is the efforts that we do in Jakarta to mitigate these pollutions. We do the vehicle emissions tests for all of the vehicles and the age of the vehicles itself. We also spray the roads when the pollution really high, and during those critical time, the government also shut down some of the office in Jakarta just to reduce the mobility in the center. And this is another problems. Traffic congestions. Why I'm raising this? Because the air pollution is actually caused mainly by the traffic congestions in the city. You can see we have cars and we have more bikes in the city, including the taxi, the bike taxi. And you can see this is actually the lane, the fixed lane for the BRT for bus, but is also passed by the cars and the private vehicles. And the congestions actually occurs around the city center and also the buffer zones, because most of the people stay in the buffer zones. And due to those problems, we need to really work on the policy. But to get the proper policy, we need the right research for that. And I've been talking about this in our national televisions, that there are factors that cause the air pollutions. And I talk with the data that we've been collecting for the past 3 years, since 2020 to 2021 at that time. But since 2021 to now, we are developing the device that one of them is actually using the GNSS. I'm also talking with the government to help to explain to the public why this happened, how is the real data, and what the data speaks for the real contributor of the pollution itself. And because everyone just pointing out the governor, Mr. Governor, in the flyer, that this is your fault, but actually it's also contributed by the surrounding area, which might be from the different states from Jakarta. And you see, I was talking just now about the fixed lane of the BRT, the bus rapid transit. And what we did was collecting the data by using private vehicles. But in this particular sessions, I'm going to talk about how we also collected the data by using the BRT. And this recent works is just published in our paper, collaborating with the Tumsat University and CSIS University of Tokyo with Dr. Dinesh as well. The integration of both GNSS technology and the dynamic air quality monitoring applications. You can check out with this title. And those are, some of my students doing the research in the bus. And also the private vehicle, Mr. Garin was doing it for 3 years, but the students did it by group. And we fixed the sensor outside of the bus and the GNSS inside the bus. But after that, we developed the integration of both technology itself. So he's going to talk about that more, because I think he was working very much on this in details. Please, Mr. Karin.
Okay, thank you, Dr. Lin. I will continue. So this is the system that we designed, this one, the integrated system. So we move from the non-integrated system to the integrated one. So as you can see from the non-integrated, we use the GNSS receiver and the HT CO2 meter. So as you can see, in this non-integrated, we collect the data separately. And when we design this integrated, the GNSS receiver and the MH CO2 sensor collect the data together. And with this integration system, we use Raspberry Pi to integrate both of the devices. So these are the scope of our study. As you can see, the routes, main routes of Jakarta, and the schedule, the day and time. And these are some results. You can see the distribution of vehicle speed. So we could see the distribution of vehicle speed by color, and the cause of the traffic congestion because of the lot of physical features like multiple roundabout and some of U-turn and some busy area of the main routes. This is also the example of the congested area. And this is the distribution of the vehicle speed and CO2 by colors. As you can see, the value of both variables. And this is also the example of the result from vehicle speed and the CO2 distribution. And for the architecture system, this is the the left one is the non-integrated for the single point positioning or SPP. And if we want to use RTK, it's also possible. We could use the base station. So the weak point of this non-integrated system is in this part, the manual integration with Excel. It will create a lot of error for the time synchronization and the loss of data. So if you see the architecture system of the integrated for both SPP and the RTK, the integration process will be on the Node-RED software of the Raspberry Pi. So besides the spatial data from the GNSS data, we could get the environmental variable, that is the CO2 variable. So these are the interface of the Node-RED program that we built with JavaScript programming language. And unfortunately, we found some faulty with the loss of data that we're still working on. And we did the statistical analysis also with SPSS. So the correlation showed that the correlation is strong for the speed variable, but somehow on the CO2 is still weak. As you can see also with the graphical visualization, this is for the speed variable as well as the CO2 variables. And notes from the study that we pointed that the time synchronization and error removal technique is reliable with CO2 sensor as well as another sensor like temperature and etc.
Yeah,
Okay.
I can add on that this device is actually mainly designed to get the real-time data of air monitoring in Jakarta, because currently we just have around 6 stations to monitor the air monitoring, but it's more on the macro one. We can't spot which locations contributing the air pollution itself. So, but this would be one of the best way or fast way to get the database for the decision maker to take action, because the air pollution keep changing every day, and sometimes it get worse in the morning. So this is what we currently plan to fix it in the BRT, in our Transjakarta bus system. That's it. Thank you very much.
Thank you very
everyone.
much.
Thank you very much. Okay, since we are running out of time, so probably we will have just one question, the burning question.
Or no question.
No, unfortunately, yes.
Yeah.
Yeah.
Thank you very
But
much.
later, probably, I would like to talk with you. Yeah.
Yeah.
Thank you.
Thank you.
Okay, then I would like to invite the final speaker. Professor Fitri Yakubo is ready for presentation. And actually, there is no coffee break after this, and next session should start at 11, probably. Oh, no. Yes. 10 a.m. So probably, I hope that you could talk concise. Probably you may put your laptop just over there, yeah, because there should be a power supply. And anyway, you can talk there. Yes.
Good morning, everyone. Hi, Uzamas. Sawadee. Thank you, Shibazaki Sensei. I apologize for the late presentation for today. I'm Fitri from Malaysia. I'm not a professor actually, Sensei. Okay, I would like to present about the FlashNet more towards for the forecasting and localized sensing for hazard. Focus mainly for the evacuation and transportation network. I do believe we call FlashNet here because of this is our, I think, very big issue and current ongoing problem so far. We still don't have any solution at the moment, especially for the urban area. That's why this topic focus on the urban network transportation. If you take a look, we can see Delhi, Bangkok, Kuala Lumpur, Manila, Fukuoka, Seoul, Jakarta, Beijing, and so on. So this is the real scenario happen. And in Kuala Lumpur, I guess we have the same scenario happen more than 5 times per year. So this is very big issue, and there is no solution at the moment. If you take a look on the top 5 countries also, you can see this scenario is not only focused for Southeast Asia, but all over the world. And for the specific Southeast Asia region, we can see people that most at the risk 1.24 billion. This is based on data 2022. Image sources Kuala Lumpur 2022. This is Kuala Lumpur, not in the rural area, urban area. There are many cars stranded. We have issues on the stranded vehicles, also related to the heavy traffic jam. And we have a problem in terms of time loss and also life loss. Therefore, we begin to develop prototype by implementation of this technology solution. We have a satellite that relates with this information, communication, meteorology, position, and geophysics. We also do have IoT remote sensings. And also for the navigation, real-time traffic navigation solution, especially for the flash flood scenario. We embed our system with AI for the prediction and forecasting in order to make sure that we can have a good evacuation routes in terms of safest and also in terms of fastest. By utilize this GNSS and also other technology. This is our architecture in general. So we utilize our GPS, QGSS satellites. We also have our ground devices. So this is what basically a slightly difference in a river scenario. So we focus on the urban area. So we deploy our phase flight ground detection device. This is to double confirms the results that from the satellites information. More accurate because they are taken specific scenario and position. We have our AI and IoT platform that's to inform those information in real times for the local authorities, especially for local agencies. And also we use, we generate the route generation not only for the road user, but also for the rescue team. So we have implemented this one actually in Kuala Lumpur, but in the small scale scenario. I do have a video here, but I'm not sure is it working or not. We are supposed to have a small video about the flash flood detection system, number 1. Then we have our information that received from GPS and also GNSS. We have our centralized monitor IoT platform that use the AI edge technology to predict and display real-time information. So this is the local authority. For example, we have Kuala Lumpur City Hall, mainly in charge for Kuala Lumpur City. and this is one of the agency that in charge for the any disaster in Malaysia, which is what we call NATMA. So we have worked together with them. Even we are able to get the route generations based on result analysis come from the IoT platform and AI technique. So this is the actual pilot study we have implemented just to locate the safest routes and the safest place to evacuate. This is our basically second pilot study. The first one not in the urban area, but more on the rural area. But the second one we jump into the urban area. This is our nearby with our campus, not far, less than 2 kilometers. So we implemented along the way. So every one device cover up to 5 km, but actually it's depend. I cannot say exact number 5 kilometers, but it's range between 3 to 6, 7. So I can see this is the average distance that one device can cover for that particular area. So we don't implement it randomly. We do mapping and have a result priorly. Then based on that result, we deploy our system just to check and confirms the result based on the satellite information with the ground devices. Another scenario here, you can see this is quite straightforward. We have satellite, ground device, and stranded vehicles. Then we are using, again, imaginary satellites. This time we try to cooperate with local car automotive in our country. We do have two automotive industry, Proton and Produa. So we try to link with the navigation systems, the existing ones in the car, in the vehicles. So we send this scenario. We have our 60-second flight predictions. Again, this is based on ground devices. So if you don't have a ground device at that particular location, then we don't receive any information. So it's within the range of a flight scenario. We actually have begin back in 2021, but yeah, you know, this is issues of nations. So we have many discussion with the government agency. Even we also have site visits in few university in Japan, our partner. We also involved in community projects. This is a landslide scenario, another big issue in our country after flood. Recently this year, I think we have more than 3 landslide debris flow scenario, then kill 5, 6 people on the spot. So that's why we try to come up with the early warning message based on satellite and ground devices. But the problems for the rural area of the, we have a very specific connection because covered up by a lot of trees, but we are able to do the IoT part for this information. We are also able to send those information to the local authority. So we are targeting basically to the next phase for the software automotive industry, just to see that we are able to embed with the existing navigation system. I know a bit hard, but if nobody want to try, then we try to see how many percent damage that we can reduce time by time. Actually, this solution, I believe, in my opinion, can be implemented in agriculture, warehouse, insurance, logistic, and so on. Even agriculture, now we also have a small project in agriculture using almost the similar concept. But yeah, for this presentation, I don't have those information on this slide. This is our members. We have a few. So we have remote sensing and financial and advisor and so on. Our idea basically is we want to make sure that to have safer futures, especially I can say flood issues in Southeast Asia. I think that's all. I end my presentation. Thank you so much. Domo arigatou gozaimashita.
Thank you so much. Yeah, thank you very much. Anyway, that is a very common issues for the major Asian, cities. Okay, just one question. Any questions? Okay. Yes.
Thank you very much for the great presentations. For the flash flood system, the early warning system, I assume you combine the water level rise detections with the evacuation alert.
Yes.
Is it already implemented, or is still testing the prototype?
Now in the second phase, at the same place, the Jalan Toraza.
Toraza.
Yeah, but
okay.
not a lot, all long around. So I think less than 2 kilometers so far.
How do you place the water level sensor, because it's flash flood, right? We are not really sure which area would be implemented, will be applied.
In this case, basically, first you need to have a good connection with local authority, because to deploy your system, you must have permission from them. So in our case, City Hall, Kuala Lumpur, agreed to be part of the project. Since they have a lot of pole along the roads, they also implemented CCTV. So we also basically embed on that particular system. The idea is basically the water levels. How I know that that location have this issue? Basically, this one we do mapping from remote sensing. We already know which location that they have always occur flood. But now the problem is when the car goes through, they don't have any no more other routes. They will stranded.
Alternative, yeah.
Yeah, this is the idea.
Where do you place the sensor? Is it
at the pole, at the
pole
side?
Is
Yeah.
Permanent?
So far, just tested for the second phase, but based on local authority, they say not safe to be there.
Yeah,
because
I think so. Yeah.
you know, Malaysia people, they are still not aware of this thing.
Yeah, we are also working on this, but we are not sure where to locate that, because flash flood is totally different from the normal flood. Maybe
Yes,
we can
correct.
put it on the river
Yes.
surveys, but this one no. So I think that's the big challenge. Yeah.
True.
Thank you very much, Prof. Shibashaki.
Okay.
Thank you.
Yeah, thank you very much.
Thank you,
And
Sensei.
yeah, anyway, thank you very much for
Thank you,
the
Sensei.
talk. Okay. Unfortunately, probably we don't have kind of time for kind of, let's say, discussions for the overall presentations. But anyway, we really enjoyed the very informative and interesting presentations so far. Okay, I would like to conclude the meeting kind of session today. Thank you very much for joining.